The following content has been provided by RWTH Aachen University.
Welcome everybody to iOS application development. My name is Jan Borchers. We'll be going through some administrative details today and then jump right into what iOS application development, the class, is all about and get started with some content. Thanks for joining us on Zoom here today. We're teaching this online to keep everybody safe, and I hope you found a spot where you can actually listen to this class and maybe even throw in a comment or a question here or there. The class is being recorded, but you won't be in the video. It's just me and Phil and whoever is presenting. And so if you say something, you'll be on the recording, but you won't be seeing your face or anybody else's face in the recorded version of this class. If you have any questions, if you're wondering about anything, the best place to remember, if you only take away one thing from the class today, it's this URL here at the bottom, hci.rwthachen.de/iOS. This is the jump page for our class. And from here, you can find everything, the Moodle rooms, the YouTube channel. You can find links to documents you might need to sign, etc. So everything's there. This is the URL to bookmark and to keep an eye on. All right, so with that out of the way, let's get started and tell you who we are. Like I said, I'm Jan Borchers. I'm the head of the chair for media informatics and human-computer interaction. That's computer science 10 for you numeric folks out there. I'll be joined in this class by a couple of folks from our PhD students. First, Philip Wacker, who's actually in the channel here today with us. Then there will also be Sebastian and Adrian. So Phil will be taking over some of the lectures starting as early as next week. And Sebastian and Adrian will be helping out with the seminar and the project part of this. Because this is an unusual class in the way that we teach it and the way that it is built. It will be probably unlike most of the classes you've taken so far in your CS curriculum. And I'll tell you about that in just a second. First of all, though, what's this class about? So you can decide whether this is what you wanted to learn this semester. The class will teach you a couple of things. Of course, you'll be learning how to write iOS apps, and we'll be doing that both with the UI kit, that is the foundation of most iOS apps up to today, and with the modern Swift UI framework that has just come around the block and is sort of the new challenger. UI kit is interesting to look at, not just to learn how to program iOS apps and get rich and famous, but also because it is actually a pretty modern framework that was designed from scratch. It is taking over a lot of things from the macOS frameworks on the desktop, but it is cleaner than the macOS SDK because with iOS, the developers Apple was able to cut off a few old things that had been around the SDK for a long time, and so it's a little cleaner in its design. So it's fun to see how a modern SDK looks that has very few ties that it needs to keep running with history. And then Swift UI, of course, is super interesting. It's an intriguing new approach to declarative coding of the user interface that is definitely something you should know about, even if it's not Swift UI per se that you end up using. But this new approach is a big challenge to how we've been thinking about UI coding so far. So we'll do a lecture on that towards the end because it's not really the mainstream way to write iOS apps today yet, at least not professional ones, but it's picking up steam quite quickly. But our chair is about usability and human-computer interaction, and so we will also make sure that you understand what it means to actually write apps for mobile, right? So how to develop for mobile as opposed to for the desktop or the web, although the web could be mobile or desktop these days anyway. So what is different about how you need to think about what your app's going to do, what functionality you provide, how you provide it, how the user interacts with it. There are quite fundamental differences here that we'll talk about. And we'll get started with that topic today, right out of the box. Now, when I say you learn writing iOS apps, of course, you'll learn Swift as the language of iOS that's been around for many years now. So we won't be bothering you with Objective-C anymore, although we used to do that. You will learn also how to use some advanced iOS frameworks, right? We'll go through all these wonderful SDKs that make your life easier if you know how to use them. Software development is very different today from what it was like 10 or 20 years ago, where you had to write a lot of the functional code yourself. Today, it's really mostly about finding the right frameworks and making your app adhere to those frameworks and use them. And those engines and frameworks do a lot of the work for you. Since we are about usability, we'll make sure that we focus on user experience and usability as we go through, especially the third part of this class, the project part. Because we want to make sure that you don't just learn how to write some kind of iOS app, but actually how to write one that delights the user and that people enjoy picking up, that they feel comfortable using, that makes them feel competent and lets them do their job without getting in the way. So that's kind of like a side effect of this class. If you want to learn more about UX and usability, I really encourage you to take our class Designing Interactive Systems 1. That class is also happening this semester. And it starts tomorrow, and we just made a change because we have record application numbers in this class. So it is no longer a limited seating class. So this semester, since we're teaching online and we don't need a gigantic lecture hall for this, we actually offer everybody who would like to take this class to sign up for it. That class teaches you usability from the ground up, how to prototype interfaces, how to work with users to figure out what they actually really need, how to test your interfaces, how to evaluate them, and golden rules about good interface design. I think it's probably the most important class in the DIS1 class, Designing Interactive Systems class, that we teach if you want to round out your computer science knowledge and understand how people actually will be interacting with your stuff and how you build apps that people like. But while DIS1 is a class that's a lot about design aspects and there's even a little bit of psychology in there, so understand how people think about computers and what happens in a person's head when they interact with a computer, this class, iOS, is about a lot of coding. So you will be doing a lot of coding in this class, and that's really one of the design goals of how we made this class. Now, why are we teaching iOS? There's a bunch of reasons. First of all, we've been using iOS ever since it came out, just as we have used macOS ever since we created this chair 15 years ago or more, as our research platform. So all our research prototypes that we need to test a new interface idea, to build a wacky new interface, we've been building with iOS or macOS if it's on the desktop. And then secondly, we've also used it to build a whole number of industrial apps that have been shipped and that we've sold and that are out there on the App Store that for people to try out. In fact, you can try out some of those yourself. So here's an overview. Starting at the top left, Flap is a city tour through Aachen. So next time you get your parents visiting, I know it's an embarrassing moment, right? You wonder, like, what am I going to do with them? Download the Flap or make them download the Flap application and let them take that city tour. It's a bit different from what you normally do because it focuses on the academic achievements and the innovation and the inventions that have been happening in Aachen, and takes you through the old town and has lots of spots on there. There's augmented reality content in there, 3D models you can look at that float in the air in front of you. There's audio guide tours. It's in multiple languages and all other kind of stuff. Philip actually was behind much of the development of this application. And so he can tell you a story or two about how that happened in practice. It's out on the App Store. You got to look for Future Lab Aachen app. Otherwise, you only get Flappy Bird. Well, sorry, we can't compete with Flappy Bird when it comes to App Store ranking. Secondly, we also wrote a museum guide for the Centre Charlemagne. And that's actually been our second or third or fourth guide application that we've been writing for museums and the likes. You can also download that, the Centre guide. It's the bottom of this page in the center here. And it's the guide that everybody is using when they visit the Centre Charlemagne that's on the Katschhof behind the the Rathaus behind the town hall. Quite an interesting navigation technique in there. Again, Phil can tell you more about this if you're interested. And this goes back to, like we started as early as 2009 to start shipping products running on iPhone. The Explorer, for example, was a tour guide for Aachen that we built. Back then, we put an iPhone 4 or something like that into a custom-made case, as you can see there, with an extra battery and GPS receiver and stuff like this. And here's Corona next to it, which was a very interesting audio experience that simulates a virtual reality, but only on audio, only on your headphones. So you put on those headphones, you walk up into the coronation hall up in the Rathaus upper area, and through an ingenious tracking system, it actually simulated as if you were taking part in the coronation feast in the medieval times. But all on audio, so very interesting stuff there. And then there's research applications. As I said, we've written things to test new interaction techniques that use touch and force and pressure, for example. Or on the far left here, AR Pen is an app that's also based on Philip's work that lets you draw in 3D, and that's actually also out on the App Store. And I encourage you to download that and play with it. It lets you sketch 3D models by holding a little piece of QR code printed paper in front of your camera of your smartphone, of your iPhone, and then you can doodle in 3D. And you can 3D print what you draw if you like what you did. And finally, everybody needs to eat, right? So years ago, we started writing apps for the iPhone, and it's also running on the Apple Watch now that let you check out the Mensa menu. And that's a delightful little app that we've been keeping alive and been updating over the years. So it shows a lot of good usability practices, and you can download it for free, of course. It's called iEat. So check that out on the App Store if you have an iPhone around. Okay, so that's why we do iOS. We've actually started teaching iOS development pretty much as soon as the iPhone SDK came out. We had, I think, the first event about how to write an app was a day after that we had for folks at our lab. And so we've been doing this for a long time. Now, a couple things about this class. 6 credit points, of course, 6 ECTS, and the class times are known. It's today at 10:30 to 12, and also Mondays 12:30 to 2. We teach online via Zoom, as you know. Since we had so many registrations, we really had record applications for this class. We felt honored that so many of you want to take this class, which is really wonderful, and I would love to take everybody. But unfortunately, the format of this class and the way that we want you to learn iOS development doesn't scale all the way to 200 people. But we doubled the number of seats. We originally had 42 seats. Now we've got 84. And so that is an improvement that we did put in place. So we'd be able to take a few more people from among you than we originally planned for. The links will be to the lectures and the Zoom setups after this first class will be in Moodle. So you need to be registered to get to those so that you can join the future Zoom classes here. And understand that the class times will stay, but what we're doing in these times will change quite drastically. And that takes me to the syllabus. The syllabus for this class is unusual because we will first start with a quick-paced, high octane teaching segment where we will cram as much about iOS and Swift into your heads as humanly possible in just a few weeks, right? So we will really get you up to speed. And we can only do that because you guys are all RWTH Aachen students and you're all awesome programmers. So you will pick it up, right? We trust you. Otherwise, the stuff that we do in a few weeks, Apple recommends as a curriculum for like a whole year, right? So it's high intensity. So you need to keep up. But we do this because then it gets interesting. Then in part 2 of this class, the second couple weeks, we will actually give you a chance to show that you can dive deep into your favorite framework, right? So we'll take some of the advanced frameworks and we won't be continuing our frontal lecturing here. Instead, it will be seminar style. Each group of students gets a framework and they get to dive deep into it, try it out, play with it, and then report on their results and give a little presentation for everybody to understand what these frameworks are about. And don't worry, before any group comes up on stage and tells everybody, we do a little quality check so that, you know, as a student listening to your fellow students' presentations, you don't waste your time because they don't know what they're doing, right? So everybody will be, we will do a little, you know, quality assurance here on the way. And then this frees up, you know, the last part of this class, which is the most fun one maybe, which is app development, right? So you will do a project in your groups, in your teams, and you'll be writing your own application, and we'll tell you more about that as the time comes around. Now, how do you get your grade from this? We split it up, right? So we've got 70% will depend on how you perform in your seminar talks, and how you present the SDK that you got to dive deep in. 50% will be on the project, so that's a lot, as you can see. And there'll also be the final exam, which will make up only 33% of the grade. So that's how your ECTS grade is combined in the end. So what that means is it's one of those classes, I like doing this with most of the class we teach, that keeps you working throughout the semester. I know you all work throughout the semester, right? No one of you like only waits until like 3 days before the exam to really learn, right? You never do that. But because I know you don't do that, I want to, you know, reward you for your wonderful learning style that you have. And so we're giving you points and, you know, points towards your grade even before you enter the room on the day of the final exam. All right, so what's going to be the topics that we go through? In the lecture segment here, we will introduce you to Swift. We'll talk about Xcode, how to use it, of course. We'll introduce you to UIKit, and that will be most of it because that's the toolkit that everybody is using these days still to write professional grade apps. But we'll also talk about Swift UI a little towards the end. And then we'll get into all the topics that are tricky about, you know, building great applications, right? How do you let people navigate among screens? I mean, you only have one screen at a time usually, right? How do you animate these transitions so that users don't get lost? How do you customize standard views if you need something else? How you deal with collections of different types? How you do auto layout, which is you know, an automated way of laying out the interface for you, so you no longer need to decide exactly at this pixel or this, you know, percentage I want to place that user interface element. But it can be tricky to work with because it has to take a lot of rules into account to lay out the UI, and it may not always do what you want it to do. How do you do persistence? How do you store stuff when people, you know, leave the app? Where does data go? Where can you store it? And how do you network? Of course, you need to be online these days with apps. And then how we bind between code and the user interface, how do bindings work? And then what is the comparison between UIKit and Swift UI in particular? And there may be more topics on that in that direction, but that's an example of the things that we will be covering. Now, we'll be going fast. And if you want to read up in more detail, please get these books that I'm showing you to the right here. They're free. You get them on Apple eBooks, on Apple iBooks. And they're ebooks, so you can download them for free. And they've been split up in two volumes recently. They used to be one volume. The first one is the fundamentals one, and the second one is about data collections and goes a little more deeply into advanced topics. So get these ebooks. And whenever you feel that you didn't quite catch something that we did in class, go back to these books. We actually aligned our teaching syllabus to match what's happening in these books, so you will be able to find your place in the book to read up in more detail about anything you didn't catch. Okay, so now what are some topics for the seminar, that second part of the class? I just listed a few things, right? Core animation, haptics and sounds, Sprite Kit, working with files, the combined framework, which is interesting, again, towards declarative programming, debugging in Xcode, widget kits, Siri for not just for voice input, but generally for intelligent assistants, web views, map kit. Of course, you know, a lot of people need to show maps these days, presentation controllers, and of course, the interesting recent SDKs that support you in building machine learning based apps. So to add a little bit of AI into your application, of pattern matching, of shape recognition, voice recognition, etc. core data as an important storage format and a really interesting way to not having to deal with the ins and with the intricacies of storing files. Watch OS apps, so we go beyond the iPhone and towards the iPad and also the watch and show you what's different there. Scene Kit to give you a little bit of 2D and 3D graphics fun, and then Swift UI as the sort of new way of doing things, and how does Swift UI tackle the whole question of layout. And of course, Metal, for those who want to get their hands really dirty, you can go down into the graphics APIs, and this is what you use if you need really high performance graphics. You need to squeeze the last bit of performance out of your app, for example, for a highly immersive high frame rate game, for example. I should say that also in the seminar, we will be recording those seminar talks, unless you have an objection with that. If you do, then please let us know. Drop Phil an email, because we want both you to have a chance to see how you perform in your seminar talk, but also get other people a chance to watch it if they want to catch up on that topic. These things happen as 15-minute presentations, and they'll take place in November and December. And what you'll be doing is you'll give a quick overview of the framework and show some sample apps that you wrote. And that way everybody else will get an idea of what that framework is about. And if they really need it for their own project, then they can dive deep into it. Attendance, and this is important, please everybody listen up. Attendance for this part is mandatory. It's a seminar, right? Seminars always require attendance. So you need to be there, right? If you can attend this class here, we very much appreciate it, because it's no fun talking to just, a camera. But for the seminar, you got to be there, right? Otherwise, if you miss more than one, you're going to be off the class. So make sure that you have these times for this class free in your schedule. No early skiing vacation for you this year, I'm afraid. That would have to happen some other time. As I said, this is 70% of your final grade. And then the project will kick off after the seminar talks in December. So we want to make sure that you can get a head start over the break to think about your project and to start doodling some ideas and stuff like this. We'll announce the topics at the kickoff date, because we usually give people a frame of reference for the things that they should be developing. We won't tell you exactly what to build, but we will give you a domain and a challenge area to be in. These apps will show you how to code for the App Store, but your final app you won't be submitting to the App Store. You'll be submitting it just to us, just to keep a little bit of administrative overhead out of the process. You'll present this with a live demo, and code documentation is super important. And this, as you can see, makes up a big part of your grade. So this is where you show if you actually understood what we taught you. Or maybe you knew it all along and you're already a great iOS coder and you're just here for the easy credits. That's fine too. If you want to do that, that's totally okay. Written exam then will be asking you about things from the lectures, of course, but we'll also be asking you about things from the seminar. So that's another reason why you want to attend all those seminars and listen to what people are telling you, because we will be asking you about some of the things that were being discussed in the seminars. We still need to find some exam rooms for this, because we doubled the number of attendees here. So we're still working out the details for that. But that's also why the exam dates are still preliminary. So they might change, right? But for now, we're planning to do these in February and March. It'll be a 60-minute exam and makes up for a third of your grade. All right, what should you be bringing to take this class successfully? We expect that you have object-oriented programming experience, right? So we won't be explaining what a class is or what subclassing means or an instance and stuff like this. Because we'll be diving into Swift, assuming that you know an object-oriented programming language. Usually that will be Java for most of you guys who took the bachelor's here in Aachen. You got to have an Apple developer ID, so sign up for one if you don't have one already, because you need that to develop. And you must be registered for this class in Artificial Online. Right? So you need to sign up in Artificial Online so that we can track you and put you into Moodle groups, etc. It also really helps if you have a machine available to work on iOS. So this is a tricky topic, right? I don't want to exclude anybody from this class. Even if you don't have a Mac, you can take this class successfully with great results. But Xcode as a development environment natively runs only on the Mac, right? And we will be using Xcode 13, the latest one, of course, so that you can develop for iOS 15, which just got released. Now, if you don't have a Mac yourself, there are two options. The first one is you'll be working in groups in this class. So you'll be meeting up a lot in these groups anyway to work on your assignments. And so if one person has a laptop, it usually is a great experience to do some pair programming where at least one other person or maybe two other people are sitting around and you work on these things yourself. You can do that remotely by screen sharing, or if you're all vaccinated and you keep proper hygiene and distancing rules, then you can also, of course, do that in person. If that is, there's another option, but I will say that we haven't tried this, but the internet say it's possible. You can run Xcode in a virtual machine on a PC. If anybody has done that successfully, please drop Phil and the other students a line, because we really would like to hear from you what your experiences are, especially with Xcode 13 and iOS 15, the latest versions of this. That's a possibility, but it's not officially supported by Apple, and we don't use this because we use Macs for everything. Oh, cute dog in the picture. Thank you, Tarek. And so we won't be able to support you in doing this, but it's an option that you can explore if you don't have a Mac around. Finally, if none of these solutions work for you, we also have a limited number of devices that we can rent out, right? We bought a few new Mac Minis, but I think it's like 3 or 4, and we have a few older machines. They won't be the latest models. These the Mac Minis that we have are pretty recent. We just bought them last year, but it's only very few. So we are willing to give these out to enable you to work on your assignments if you don't have access to a machine. But it's not a lot, right? We can't buy 84 Mac Minis for everybody. And so these are available, and you will probably won't be able to hug it for yourself the whole semester. You may find yourself having to timeshare it with somebody else if we find that we have more people needing a machine than we can give out, right? So there may be something where you need to arrange times where you pass this device back and forth among yourselves. Now, it's helpful, although not necessary, to have an iOS device. Most things we teach you can easily do in the simulator. The simulator is really good, and that means you simulate your iPhone or iPad or whatever directly on your Mac. But there are some things, especially in the projects, you may get into something where you need access to a native device. Maybe you want to play with the sensors, the gyro or something, and that's something that's kind of hard to simulate. So for these things, again, if you have an iOS device yourself, great, use that. If you don't, we actually also have a few iPhones that we can, again, give out as rental devices, possibly time sharing. We have a few more of those than we have Macs, so chances are a little higher that we can help you out there. And then it helps if you've had previous experience with Swift or Objective-C, but it's not necessary, right? Object-oriented programming is all that you really need for this class. And this class is for people who have are in the programs for the bachelor or master in computer science, or who are doing software systems engineering, media informatics, data science, or technical communication, right? So these are the courses that we're aware of. Now, what I would like, Phil can check, I think, Phil, you can check what programs people are in, right? You can do that later online, right? We don't need to do a live tally, right? Okay, so won't waste time on that. But what I would like to hear, if there's anybody in here who's not in one of these programs, that's fine. We can talk whether we can make it happen so that you can take the class. But if you can speak up, is there anybody here who's not in any of those programs, who's in the call here today and who would like to make themselves known? Okay, you're wrong. What's your major?
I am from the computational social systems.
Computational social systems. Okay, great. And how about you, Suraj?
Same, yeah.
Same thing. Okay, so 2 people from the CSS studies. Great. Okay. Yeah, thanks for pointing that out. I think the class actually, Phil, might be listed there as an optional class, so we can probably include that next time on the slides. Actually, it's a pretty new program. So
I need to take a look whether it's in.
Yeah. So Björn, what about yourself?
Yeah, I'm doing civil engineering, so it's for me like a free choice to do it. I can use the credits, but I'm not like in its computation science engineering or stuff. It's
you're in a CSE.
No, it's like it's like the usual civil engineering bachelor's. I did some Python coding, MATLAB coding, and all that, but it's all alongside my studies. So like officially, I'm not studying anything concerning computational science or something.
I see. All right. Well, I mean, of course, auditioning the class is always fine. But you know, we will have to see. Phil will let you guys know if we manage to get you in there. We do have a serious overbooking, even with our 84 seats. It's really tight. So we may find that some of you guys we won't be able to place into groups. Of course, you're welcome to audition the class anyway. And hang out in the lectures and you know, do the assignments for yourself, but we won't be managing any lab process for you guys.
Yeah, sure, no problem. Thanks.
Okay. All right. Phil, anything you want to add to this? I don't want to.
Yeah, no, we have to see who can get a seat. But yeah, the preference will be given for those who can actually take the credits for their studies, since we have to filter at some point. So if you just want to listen in, more than welcome to do so. But yeah, it might not get a seat this year then.
Yeah. All right. And maybe, Phil, we can work. We can talk later whether we can find a way for people who won't be getting a seat in the class with full credit, etc., to still access the videos. We'll have to talk about that.
Yeah, well, the videos we'll make also available on YouTube, so that shouldn't be a problem.
Oh, right. Yeah. Okay, good. Right on. So yeah, that brings us to the limited seating issue. We did have 42 seats. In light of the swamp of people who want to take this class, we feel very honored. We doubled the number. And you need to attend a seminar and you need to attend your project meetings. And during the project, you're not off totally on yourself. We will be checking in on you, and you'll have assignments, you know, appointments with us to meet up and discuss your project progress. So those are mandatory. If you can't make it, don't take this class. So how do you get a seat? First of all, register in AutoPH Online if you haven't already, right? This is totally required because otherwise you're not, you know, blipping up on our radar at all. Sign the declaration of compliance before tomorrow 1 p.m. Okay, tomorrow's Wednesday the 13th, so sign it before tomorrow 1 p.m. It's linked off the jump page that I gave you earlier. If you do these 2 things, then we will invite you to Moodle to form groups. We need groups of 6 students, not 5, not 7, 6. Right? It's an integer. Not 6.5, really 6. We want 6 people in every group. I know you may have 5 because those are all your best buddies, but please add a 6th person. And if the 7th is also your best buddy, he'll have to go somewhere else. So make groups of 6 students and make sure that you have at least 2 students in each group that have a Mac, right? So that we have some way of doing at least some pair programming to get to work on the assignments, etc. Then you're not in the class yet, we're sorry to say, but this is what we need you to do. Send us an email with the group members, right? The name and matriculation number, again, to Phil before Friday this week at 1 p.m., right? Those are 2 hard deadlines. Everybody who manages these incredible hurdles, I know it means, you know, communicating with other students, it's challenging and all that, and writing emails before a certain deadline. And if you manage to do those things, you have a pretty good chance, right? We'll select out of these people 84 students grouped in 14 groups. So we will select randomly 14 groups out of everybody who did that. Okay, so that's the setup that we have right now. Now, one more thing I would like to ask you. If you know at this point, oh, I'm not going to be able to attend this class, or you cannot, you don't want to, please deregister in WTH Online. As you can see, we've got what, like 220 or even more people on the list here right now. You will be freeing up a spot for a fellow student who wants to take this class. So do it quickly. Decide now, decide this week if you want to be in or not, because that gives us a chance to give that spot to another student. Be a nice person. Don't hog a space and then give it up in in 2 or 3 weeks. That's not nice. Thank you. Lecture slides and videos will be online. Again, this is the jump page that you need to remember. You'll find them there. Those will have links to the YouTube videos that will be up there. We're hoping that we can do this with just a few days delay to get them up there on YouTube. But I do encourage you to come to the live lectures, because it'll give you a chance to ask questions, to be present, and just to have a schedule that you can plan for attending to this material. Because as you've all learned by doing online classes, it's very tempting to just yeah, I'm going to watch that later, right? Don't do that. Stick with the topic. It's going to be fast paced, and you're going to get lost if you don't stick with us. So please do. All right. That's all the administrative stuff I wanted to share. And we're now going to go into the actual factual stuff. And before that, 2-minute bio break, run off, take care of things you need to do, be back in 2 minutes, and I'll start with developing for mobile platforms. All right, I'll see you in a second. Phil, you want to go to a breakout room with the two of us?
Yeah, sure, we can. Let's see if that works.
Oh, but before we leave, Robert had a question. At least your hands up.
Yeah, thank you. I just had a question about organization of the course. Will this also be offered next summer semester?
Yeah. We're planning to. We've been offering this every summer. No, sorry. Next winter. Sorry. Yeah, next winter semester. It's offered on an annual basis. It's always a winter class.
Okay, great. Thank you. And
Sure.
if we register, if we do a free registration over RWTH Online, can we still join the Moodle and just sort of watch the lectures and follow along with the seminars without actively taking part? Or do you want?
That's exactly what I was wondering about. Well, it's a good point, Robert. Thank you. And that's something we need to work out with Phil and I. It might be tricky because it might mess up our Moodle channel, because that's usually only people who are taking a class for credit who are in there. But I understand that you want to get, maybe access to the live Zoom links rather than watching the canned videos. And I wouldn't mind personally people joining us live on YouTube on Zoom. But we need to find a way to make that happen.
There's an easy way. After this week on Friday, I will assign essentially everyone to who gets a seat in the class. So let me know next week, because I can add manually people to Moodle, but doing it at the same time will get messy really quickly. So this week I'll set up the official list who gets a seat in the class, and then next week I can add you manually. That's no problem. Okay, so you want us to, if we're not going to actively take part, sign out completely over RWTH Online and then email you next week so we can be manually added? That would work perfectly for me. Great, thank you. All right, cool.
All right, I guess that was our breakout room.
Totally fine.
We're going to just stick around. All right, welcome back. All right, quick show of hands here. This is where you get active. Can you raise your tiny little yellow hand if you have developed an app for a smartphone before, whether it's iPhone or Android, or I think there's Windows Mobile, right? Is that still a thing? I don't know. Okay, that's quite a few people actually. Nice. Looks like we got about 20 or so. Interesting, good. All right, so we'll see what you think about this. If you haven't done mobile development before, then this next part should be especially important for you guys. And even if you've done it, maybe there are a few things in there that will make you rethink what your mobile apps are doing. Because what is the biggest difference between mobile and desktop development? I mean, there's lots of differences, of course, screen size, and blah, blah, blah. But to me, the biggest difference really is if you're imagining a user who is working with your app on a desktop, it's pretty unlikely that during their work, they get hit by a bus. If they're using your app on a smartphone, that is not at all unlikely, right? And what I'm trying to say with this is that context is super important with mobile. The fact that people are using mobile apps on the go, in between, temporarily, sometimes even just for a few seconds, is so fundamentally different from what people typically do with desktop apps that it really takes a rethinking of how your app works, what it offers, what kind of things make sense to put into it, and what kind of things you need to leave out, where you need to simplify. Just to illustrate what that means, here's a little video that's was taken by a surveillance camera in a US shopping mall, and I'll just let that run for you. There's that lady working on her smartphone, and ooh, there she goes.
And she gets out, all awkwardly walks away.
Oh my God! Play it back, do it again, do it again.
I love the fact that these guys at the end say, "Oh, let's watch that again." That's so much fun. You know, what you're hearing is the security team that's reviewing the security footage and having a ball. So the point here is context is key, right? You need to think about the fact that when people use a mobile app, they often have little time, right? For example, I might be, leaving the dentist, trying to add the appointment that I just made with him, but I'm on my way to my bike to get on my bike and leave, right? I'm on a schedule. There is attention split, right? People are not fully paying attention just to your smartphone screen because they need to make sure that they don't run into a lamppost, or they might be, actually talking to somebody else while they're adding something on their smartphone. So a lot of the stuff that's happening there your app only has part of the attention of the user, and that's a tricky setup to be in. This is also often called peripheral use, right? So you're using your smartphone maybe to see if there's any new posts on your social media, but you're not really fully engaged with it. You're still, part of a social group with people you're hanging out with in real life at the moment or something. You're moving around, right? You might get hit by a bus. You need to watch out for traffic. And also the times that you interact with it are often very short, right? There's examples where people just get it out, check the weather, put it back in, right? So it's very, very intermediate. So that needs a lot of attention. And that applies to Android just as well as it does apply to iOS, right? So what that means is everybody realizes the smartphone screen is smaller than a desktop screen, but you can't just take your screen and make it smaller. You can't just scale down your desktop user interface and put it on the smartphone screen. People actually did that in the beginning, and it was horrible. Not only were all the buttons way too small to actually click reliably with your big fat fingers, but also it was completely overloaded with way too much detail to take in at a glance. So we need to rethink what our mobile apps do when we move away from the desktop. And that's the situation you will find yourself in quite often. You'll work for a company that says, well, we got this business application that everybody's using, and we want to do a smartphone version of it, right, for people to use on the go. It has to be simpler. People usually interact with only one screen at a time. So you can't have exhaustive palettes. You don't have toolboxes. You don't have windows updating in the background. You have nothing at the user's periphery usually when they're interacting with an app. So no mail icon with a number of unread mails while I'm in another app. No list of buddies in your messenger apps while you're doing this. All that doesn't exist. There's only very simple status information in the status bar, right? That's all. And even if you can multitask, which you can, of course, with today's smartphone OSs, you only have one application in the front at one time. Yes, iPadOS allows split screen, so this is changing, but that's because iPadOS is trying to go back to situations where you are working more in a productive mode, in a desktop-like environment. It's a bigger screen, right? There is no split screen on the iPhone, and it's clear why, because it just doesn't make sense for the usage scenarios that you have on a smartphone. And even if you do have the option to have two apps next to each other, switching applications, I don't know about you, I find it really convoluted if you compare it to the desktop, right? On the desktop, you've got all your windows open at the same time. You're doing this, you're doing this, you're just moving your mouse over, typing a note in this note application, moving over to the Safari, working in your browser for a while. It all is happening smoothly. We've gotten so used to it. This has way more cost associated with it if you change between tasks on the smartphone. You need to like go back to the multitasking menu and move to this different screen, and it's way more effort. There is no space for on-screen help, right? It doesn't exist. There's just no room for putting up tool tips for everything all the time because the screen is so small. So your interface has to be way more self-explanatory than on the desktop, where you can easily provide tool tips and a help menu and a little on-screen tutorial and all that kind of stuff. It's really tough to get that kind of information across on a smartphone. So got to be simpler to use. And of course, the input is different, right? It's direct touch or maybe pen, which is very different from using the mouse. For example, if you've ever tried to hover over something on a smartphone or even on a tablet with a pen, it's hard, right? The pen maybe supports it, but you can't hover with a touch. It doesn't exist. Either you touch an object or you don't. So the whole state of interface that you have on the desktop, where you can hover over a target and then pop up help or already highlight it for people to see that you're going to be selecting that if you prick, doesn't exist, right? That we lose a whole state in the state machine of interaction between not selected, highlighted, and actually selected, right? Okay, so what that means is you need to rethink, right? If, for example, you have a photo editing app on your desktop, it will offer all these fancy features like Photoshop has, but if you move it to the smartphone, it doesn't make sense to replicate all of that on the smartphone, right? For example, you'll find that some of the things, even if you look at the Photos app on the desktop in macOS versus on the iPhone, some things you just can't do. You may not be able to, for example, create a new album or to give names to pictures, and that was dropped off, intentionally, because it is an activity that is too complex for the small interface. It won't be able to do that well. So it's a really interesting exercise to go through, to take a desktop app that look at the mobile app for it, and then look for what's gone. What did they not carry over? And if it's done well, you will hardly notice, because if it's done well, it means that all the features that the design team dropped off the mobile app are the things that you don't really want to do in a mobile setting anyway. And that's the ideal state that you want to be in. Okay, so of course, there are also rules that do apply to the mobile area, just as they apply to the desktop. And what I've pulled out here are the 10 golden rules of interface design. This is the content of one lecture. I think we managed to go through this within one lecture in DIS1, in Designing Interactive Systems 1, the class that starts tomorrow. And one of the lectures is about these 10 golden rules. And I won't be able to go through all of these here in much detail, but I want to explain very briefly what they mean, because these are rules that always apply when you build an interface, no matter what the task, what the user, what the context is. Keeping it as simple as possible, which means, applying to, figuring out what your users are, what their background are, and then designing and understanding what the tasks are they want to do, and then designing for that, rather than overloading it with things nobody wants or needs. Speaking the user's language just means basically not using technical terms, but using terms from the application domain. If somebody's in an application for banking, they want things to be called money transfer and not a new file or something. Being consistent and predictable, that just means not to surprise people in ways that the application works that they didn't expect, and to use the same gestures or interface techniques for similar situations. And that's quite relevant for mobile, right? So don't invent your own multi-touch gestures if there are already established gestures that Apple, in this case, proposes for particular interactions like zooming or deleting an item. Providing feedback means that you always need to keep users, informed about where they are, what they can do here, and what just happened, and how they can get back to the stage before. But you can't clutter the screen too much with this, right? So progress bars and things like that are tricky to do on mobile because you don't have that much space. Well, you don't want to overload the user's short-term memory. That's rule number 5 here, which basically just means don't ask them to type something in that you told them 5 minutes ago in the UI, right? Don't let them choose a username and then never display it again, and they need to remember what name they picked. Avoiding errors and helping them to recover from errors and offering undo is also a super important rule. And that actually is quite relevant on a mobile device, because you will find that most mobile devices don't have the space to offer things like a dedicated undo button, right? You can do that if you want to, and iPad apps often offer it, like for drawing apps, for example, there will be an undo button, but oftentimes there is an undo gesture. Now, what is that gesture? Gesture-based input is great, but it also is terrible because gesture-based input is completely invisible. There's no way for me to know that a gesture is available in a user interface unless I already learned it, or there is some text on the screen that tells me that this gesture exists. So gestures are really a tricky beast. And all this swiping in from the right and left and from the top and from the bottom and from the middle of the screen and which direction and where do I stop? Apple themselves have not done a great job in this respect because it's a severely crowded space right now, the gestures you can use even on standard iOS. And I don't think there are that many people out there that know all these gestures by heart. So gestures are tricky. Designing clear exits and close dialogues so people know when they've completed a task. It used to be that your smartphone had a home button, right? iPhones had a home button down here. And that was a wonderful design because it always gave you a hardwired back to a safe place button, right? If you messed something up, you press the home button, okay, I'm back on the home button. Well, then the home button started getting overloaded, right? You might remember when we started having multiple screens of icons, the home button got overloaded to first take you back to your current home screen and then back to the first home screen. Then a double tap started being for, triggering Siri or triggering a multitasking menu, et cetera, et cetera. And these days, we don't even have a home button anymore. It's become yet another gesture. So having a clear way to get back to safe places of interaction is actually not easy on smartphones. Now, you can usually rely on people knowing the default system gestures for example, for getting back to the home button. But don't overload things with inventing even more of those if you don't have to. Including help and documentation is tough. As I said, there's little space for on-screen help. You don't have a menu bar, right? On a GUI, one of the wonderful things of a desktop GUI and its menu bar is I can drop down every single menu and I will see every command there is that I can do in this application, right? It's laid out for me. I can see, I can explore. That doesn't exist in mobile, right? If it's gestures, I need to somehow find out about them. Usually, you're also expected to offer shortcuts for experts. For example, you often see that when I don't need to go into a detailed view of, let's say, a note application for a note to delete it. I can delete it in the list of notes, right? By just right swiping or left swiping or doing whatever. And those are shortcuts for experts, which are great. But often these shortcuts are gestures on the smartphone. And again, gestures are hard to find out about. There are some gestures I didn't know about until like a year later when I was like, oh, what just happened? I just discovered a new gesture. And your app shouldn't be an adventure game, right? It should be easy to understand. Well, finally, rule number 10 just says, be aware of your own limitations when it comes to excellence in graphical design, okay? If you're an engineer, you're great at coding, you may or may not be great at drawing. Experience tells me that you probably aren't, sorry to say that. So hire a graphics designer. They're extremely good at things that you're not good at. And so it's a great addition to a team if you want to write a professional app, especially in this extremely crowded app space on the app stores. If your app doesn't look extremely polished right from the get-go, people won't even download it. Or if they do, they will download it and then delete it, or not even bother to delete it and just leave it hanging on the device and never open it again. So here are some examples of different applications. To the left here, we see the clock application currently being set to be the stopwatch. And some of the things we can see here is it's borrowing ideas from existing interfaces. So it's building on users' experience about pre-smartphone stopwatches. It's also putting the most important content front and center, and it's giving you fairly simple options here, right? Lap, start, etc. We could do a ton more with the smartphone stopwatch app, right? We could store 15 different lap times and have all these weird options, but we don't, because we don't want to overload the UI. The weather app is another example here that we're seeing that is, in this case, using a theme. So you're directly associating it with the topic of the app by putting this picture in the background here. It's giving you, again, the most important information front and center, and limited access to details, right? You don't get all the details you get in a desktop weather app because there's not enough space for it. Mm-hmm. Or take this navigation map. I think this is actually the Aachen bus app that you guys might know from the AVV. And again, we can see it's limiting itself to a few things, showing you the locations nearby, letting you search for a particular station, finding and saving a few journeys. But it's not everything, right? It doesn't have a map of the whole network, for example. That wouldn't fit on the screen and would be way too hard to explore on that screen. Now, when we say we develop for iOS, we actually talk about a whole bunch of devices, right? We got iPhones, iPads, the Apple Watch. The iPhone itself has gone through a whole number of different aspect ratios and screen sizes. And what these devices did when the iPhone was introduced in 2007, as you all know, it kind of revolutionized the whole phone business, because there were no smartphones before the iPhone came out, at least none that had been commercially successful. It also introduced multi-touch for the masses by making a very bold design decision, that will give you headaches to this day. It doesn't have hardware buttons. It doesn't have a hardware keyboard. You may remember those BlackBerry devices with a tiny keyboard at the bottom and a small screen at the top. Those were easier to type on because you had keys to feel and to type on even with your eyes off the screen. That won't work if you type on a touch screen. Your fingers will just drift off the keyboard. So eyes-free typing is hard on a smartphone without a keyboard, but it gave the designer and the user so much more space to show content and to really tailor the UI to every specific application, right? So the UI for a mail app could be completely different than the UI for the phone app, and it could use it could display a soft keyboard that's actually optimized for the task at hand. I don't need an alphanumerical keyboard if I'm typing in the phone number, right? So, or if I'm using a calculator. So that's why there are a lot of advantages with going all screen and no hardware buttons. If you're developing using the iPhone SDK or the iOS SDK, you can write apps for the iPhone, the iPad, the iPod Touch even, and the watch, right? All these things are out there. Now, what does it feel like to write applications? iOS is a very app-centric environment, and that makes it quite different from the desktop, because the desktop essentially, you work document-centric, right? Every application will store things in files and folders, and applications can access other applications' files and folders easily. The user organizes their whole content around their own file and folder structure. That's how it works on the desktop. This is not what you do on mobile. It's app-centric. So that's a very big difference, because Apple originally didn't give you any options to store files and folders. It only came back years later with the Files application and the tie-in into iCloud and the iCloud Drive. Apps should be doing one thing and do it well. There's usually one app per task. So you have to define the task that users should be accomplishing with your application. don't try to write Photoshop for the smartphone. You know, a typical app that's mobile will do one thing, like it might be an app to apply a particular kinds of filters to photos, and that's it, right? You don't need more in there. You can't build Photoshop for mobile and expect it to have the same breadth and depth of functionality. It doesn't make sense. Data is typically stored per app. Data exchange between apps is still tricky. It's gotten much easier in recent years, and it's kind of moving towards a more document-centric environment. But most apps that don't have a document interface, you know, I mean, Pages on the iPhone, of course, has a document interface, but you know, the weather app doesn't, right? So the kinds of weather reports that I configure for the cities that I want, I don't have any way to get to that and to get that data easily as a user outside the weather app. It's not shared. It's really more like preferences on the desktop that are typically application specific. A lot of apps still store most of the content, for the user at least, feeling like they were just application specific preferences and application specific data. So when you design your application, you got to make it really obvious how it's used, because as we just learned, there is very little room for on-screen help. We typically sort information from top to bottom. Here we can see the example from a stopwatch again. The most important thing is the current time that's been passed, and then the buttons to stop and start the watch and maybe reset it. And below that, we've got extra things like lap round times and options to switch to other functionalities in the clock application. It could have even been a design decision here to write an application that is just a stopwatch and that doesn't have all these other applications that are watch related or clock related available, right? That would have been perfectly fine. We use visual weight for relative importance. As you can see, the time is really big up there, the current running time, the buttons are really big, and then below that, the laps are much smaller. If we look at that, your reptile brain immediately links onto that number at the top there as obviously the most important thing to look at. We use alignment for groupings and hierarchy. So you can see here, for example, the 3 laps are aligned similarly. They're bunched close together, but they also have the same visual layout, so they become a visual unit. If you want to learn more about the laws that govern our layout, our way that we perceive interfaces, again, Designing Interactive Systems 1 will tell you a lot about this. There's a wonderful lecture about Gestalt laws that we do that tells you how the human brain processes visual information and groups it into entities. And there's a whole lecture about visual design that tells you a lot about screen layout and typography and how to properly use white space and how to lay out things that will make you a better designer, whether you're designing posters or your next graphic in your thesis or a user interface or a website. So those visual design and the Gestalt laws lectures are also important content from DIS 1 that you'll be able to use to your advantage here. Here's another example. The Notes app on the phone here. If we launch that, we end up first in an accounts view, and then in that accounts view we get into an overview of all the notes. And then if I click on one note, I can then add things to it, right? This is a very well-known structure called the drill down structure. This drill down navigation means I drill down until I'm at the item that I'm interested in, and then I go back up, I pop back out and look at the list of items or the folders of lists of items. So that's a very typical design. On a smartphone, you typically only see either the list or the individual item. On the iPad, especially if you turn it sideways, there's enough space to show both, right? And so that's a typical difference even between phone and tablet. If you saw that in this video that I just showed you, you may have noticed a horizontal slide, right? Activated a hidden shortcut to delete an item from the list, right? And this is what I meant by shortcuts and gestures are great, but they're not ideal from a usability standpoint because they're really hard to discover. If I don't know about this, I will never, probably never discover it, or may discover it only by accident. It also times out after a few seconds, which is another thing that I have my very personal beef with. Timeouts are an evil thing. If you want to learn more about why timeouts are always evil, check out our Designing Interactive Systems 1 lecture on golden rules of interface design. That is also, by the way, the lecture that you can go into if you want to learn more about the golden rules I just showed a few seconds ago. Now, a couple other things on mobile design. When you design your interface, you got to make sure the text stays legible, right? What that means is it should be big enough to read. So if people can open your app that you designed for your big old iPhone 13 Pro Max, and if they can still run that app on an iPhone 4, which has maybe a quarter of the screen size, it has to work, right? It has to be legible, which means it has to be big enough, but it also should never require the user to scroll horizontally. Scrolling horizontally to read is bad because I need to do that for every line, right? So we try to avoid that. Avoid an inconsistent appearance, because inconsistencies always suggest to users that there must be a reason for it. For example, here, buttons are colored in 3 different ways. And there are certain reasons for that, right? We can see that the numbers are using one color and the decimal point because it's part of the number. The basic functionalities of the calculator, the 4 basic calculation operations and the equal sign are another color. I will use those a lot. And then anything beyond that is using a 3rd color, right? So that's intentional. Don't be inconsistent without a clear intention why you're doing that. Don't use inconsistent font size or colors or appearances in general, unless you want to show that something is different. And if you want to show something is the same, use visual consistency intentionally. Your targets should actually usually be fingertip size, and that's a typo here. That should not be 0.8 by 0.8 millimeters. That would be a very tiny finger indeed. That should say centimeters. Sorry about that. So 0.8 by 0.8 centimeters or 8 by 8 millimeters is actually the original Apple recommended size of targets. Now, even Apple is, as screens tend to get more cluttered, is sometimes breaking its own design rules and are not always playing by the rules themselves. You now have a way to get back to your last app that you used in a very tiny area of the top of the menu bar. You've probably seen that if you're using iOS. And that's not a target that's of that size. And that gives people sometimes trouble because you might have people with fat fingers, you may have people who are elderly, you may have people who are young but don't have perfect vision, or they may have a slight tremor. And all these people you are immediately putting out of being able to use your interface. In fact, if you want to put yourself into that situation, if you've ever tried wearing gloves with these cool, like conductive fingertips to use your phone while you're biking, try using an interface with tiny targets with those gloves, and you'll know why tiny targets are not a good idea. Another thing that a lot of people overlook is that smartphones are actually being used mostly with only one hand. Like most people don't actually use their smartphone the way that you would imagine, where I hold it and I tap on targets and everything is wonderful. No, I mean, you've got people trying to, send a quick reply to a text message while they're carrying a bag of groceries in their other hand, or while they're trying to open their front door to their house. So be aware that one-handed interaction is very, very common, right? Also, swiping and pinching are gestures that are not fully established yet. We all know them if we've been using our smartphones, exhaustively, and we're computer scientists. We like to learn new stuff about technology just because we enjoy that process. But guess what? Not everybody finds joy in learning more technological details about something they're trying to use to get something done. That's actually a pretty weird characteristic trait of computer scientists and engineers. So a lot of people won't want to spend more effort to learn even more specific gestures just because you decided to change things around for your app to be special. It's a good idea to follow Apple's examples for gestures to keep consistency, right? And if you use gestures that are more complex, you need to provide help for them. For example, gestures with 3 fingers are extremely difficult and extremely non-standard, right? They're really hard to get into people's head. So multi-touch is great, but only use it if you actually have a use for it, if it really makes sense, right? And often it's a good idea to offer alternatives if people can't do the interaction. Because if you've ever tried to do a multi-touch gesture with one hand without dropping your phone, good luck, right? If you try to do more than one finger on your smartphone and still hold it, doesn't work. So when I say follow Apple's examples, how do we know? Well, Apple actually tells you, right? There are lists like this one that will tell you what the recommended Apple gestures are for standard operations. For example, to press or select an item, or to press a control or select an item, there's a single tap, which is like a single mouse click, basically, right? You tap and release immediately. That's what it should be. That's what you should be using for that. So no, like, tap and hold for a long time to select it. That doesn't usually make sense. Dragging is used to scroll or pan. Flicking is used to scroll or pan quickly. And here you can already see the challenge, right? I need to distinguish between drag and flick. And Apple gives you gesture recognizers that will do that. But they're not that different, right? Swipe, for example, in a table view role, which means it's one that shows lots of content, like a list of emails, is often used to reveal a delete button, right? And if you are a programmer, you can already see dragging and flicking. To distinguish these, you actually need to look at what happens at the end of the gesture, right? It's a movement from here to there. I get a touch input, and then I get a few more touch inputs that go off to the side, and then it takes off. So where's the difference? Well, the difference is in drag, the user stops and then releases. So at the moment of release, there should be no lateral movement in the move gesture anymore. The speed vector should be 0. In a flick gesture, people actually lift off while they're flicking. And so they lift off with sideways velocity. And that's the kind of stuff you need to recognize, or that you need to make sure you pick the right recognizer that Apple provides to distinguish between these things. And then there's double tapping to zoom in and center a block of content or an image. And also Apple provides, says that you should double tap to zoom out if you're already zoomed in. So that means it's basically a two-way zoom in and zoom out. But we've seen other ways, right? For example, there's the 2-finger tap to zoom out that's often used in map interfaces. Pinching open and pinching closed is zooming in and zooming out, and that's become adopted quite quickly. People understand that because it's a very physical gesture. It's really like stretching something to be bigger, right? So it's an ingenious choice by the designers who came up with this gesture. And touching and holding should trigger things like, in editable text, for example, show a magnified view to position your cursor more precisely, or things like that. And that is actually also something that, over the years has changed. And nowadays you can only do that when you touch and hold on the space bar, right? Then you get that cursor move. When you're designing your UI, you're designing for a bunch of different resolutions and roughly 4 different aspect ratios. First of all, your device can be oriented in portrait or landscape. And then, so Apple decided to give you a couple different size classes, basically, that will automatically trigger when the user does something. For example, if you have a smartphone that gets turned to the side, and it's, for example, someone takes the iPhone Pro Max and turns it to the side, that's so wide that you can start using a wider screen layout, right? You can change you will get back a different layout classifier there. And the iPad, of course, you can't just increase the resolution of your interface. It doesn't make sense just to blow up your interface to the iPad, because then you get big old buttons that are way too big and that are wasting space and that are hard to reach because they're so far apart from each other. So the iPad interface, again, has to be different, right? Here's an example. This is the Apple Mail app on the desktop, right? And then if we look at what happens to this, we've got our list of mailboxes on the left, we've got the overview list of the current mailbox in the middle, and we got the current mail on the right. Now we go and check this out on the iPhone. On the iPhone, this is actually 3 different screens. There is a list of mailboxes, then you got a list of these different emails, and then I can go into one of these emails, and then that's the 3rd screen in the drill down. And if I want to reply, I actually get yet another screen, right? So that's a very different design. Now let's look at that on the iPad. Here we can see in landscape view, we actually have the list of mails and the current email side by side. So two of these things fit on the iPad. But we're not seeing that third row or column, sorry, that the desktop was showing. And if you go back to Portrait, we get this, where you have to select, the list of emails is no longer a permanent thing. It only appears temporarily overlaying over your main content to let you quickly pick another email, right? So this is interesting if you see how actually these different device classes change the way that we interact with the device. And one other thing that I just wanted to put out there, because I think it's a wonderful distinction that you can think about. I like the distinction between lean forward and lean back interactions. What you're doing when you're working with your laptop is you're leaning forward. You're leaning into the keyboard. You are creating content. You're engaged with the content. You are modifying things. You're editing. You're doing fine, detailed interactions. You need a lot of precision. You need speed. You need power in active possibilities. When you take your phone to chat with a friend or to swipe through your emails, you're in a lean back interaction. Right? You don't need a lot of detailed precision interactions there. You want a simple interface that doesn't clutter the content that you're looking at because the screen is small, but you're consuming content, right? And on the iPad, you can have both. If I'm reading the news on the iPad, then I'm in a lean back, like on my couch, leaning back like a newspaper, right? Like a book I'm reading. I'm in a relaxed content consumption situation, but I can also use my iPad maybe with a keyboard, or when I'm drawing on it and sketching, then I'm in a lean forward. I'm in an active media creation content. So consumption versus creation is a big difference. And I like you to think about what situation your user is in when you're writing your app for them, right? Is it a lean forward, engaged content creation thing, or is it a lean back, relaxed media consumption thing? Few things about launching. You know how most apps, when they start, have a brief sort of splash screen with an about window? We don't do that on mobile. Again, it's frowned upon because it gets between the user using your app. Because if I'm launching an app on the desktop, I'm probably going to be working with it for many minutes or maybe hours on end. On the smartphone, it's just extremely briefly. And I don't need a distinction between the first time launch of an app and when I'm bringing it back to the foreground. It's not really necessary. So what you do is you show a launch image that closely resembles the first screen of your app. That's actually what, for example, the Stocks app does. It shows you already an empty Stocks app window, and then it fills in the content as soon as it's able to pull it off the web, which can take a few seconds if you're on a slow internet connection, right? If it already ran and it's just coming back to the foreground, apps will always restore the state of last run. That's, again, quite different from what you are used to. This whole frozen state that apps can be in on a smartphone is something we don't usually see on the desktop. On the desktop, an app is either running, yes, it can be in the foreground or background, but it still has windows open, partially overlapped, etc. But it's always, ready to continue. And apps on a smartphone OSs like iOS have this state where they have been removed from the screen, so they no longer have access to the screen, but they need to be ready to be launched again, relaunched, and get back unfrozen, so to say. By default, apps launch in the device's current orientation, if you don't have a specific user request to do it otherwise. And you can provide an onboarding experience, like a little tutorial. A lot of games do that, right? They tell you, oh, this is how you jump, and this is how you shoot, and this is how you run. But if you do that with an application, it's tricky, because the moment I start the app, I want to use the app. I don't want to go through a tutorial. So I'm going to click through the tutorial real quick, and then I'm using the app. And then, 3 minutes later, I'm like, okay, so how do I run again? Or how do I jump? I know I need to do this. And then if the information is no longer accessible, they need to go back and look at the whole tutorial, the onboarding tutorial, right? That's not good. So before you decide to design something with onboarding experiences, make every effort to just make your app as easy to use, so easy to use that all its features and tasks are just intuitive enough and easily discoverable, so I don't need it. as I said, your apps don't have a quit item. That's something that, you know, will actually puzzle developers who come from the desktop. Like, what do you mean I don't have a quit button in my app? Do I never quit? Well, it's tricky, right? Because your app can actually be moved to the background at any time, right? The user can just switch to a different app immediately. So at that point, you're in this, like, you know, background state. And from there on, if memory gets tight, or if the user decides to just, you know, relaunch an app because he thinks that it's doing something he doesn't want it to do, you can just get killed from that background state where you're not running, right? So, or your program could be interrupted in the middle of it running because a phone call comes in and the interface changes to this phone overlay. So whenever you get stopped by these things, you need to make sure that you store your state. And this sounds so easy, but it's so hard to make a good design decision about this, because there may be some aspects of state that don't make sense storing. You know, let's say a user just started typing in a few letters to save a file, and then he moves to a different application. Do we save those partially typed letters or not? You need to make a decision about that. A user just zoomed into a photo way, way far, like really zoomed in all the way, and then moves to a different app. When he comes back, when he kills that app and later relaunches it, should it restore that zoomed in state that he was looking at? Or was that just a view and we go back to the overview of the whole picture to give people a context where they are? It's tricky. So also there's a lot of limitations that get put on you from external sources that don't let you do all the things that you might want to do, right? You know, location services. So you have to tell people, if you don't give me access to location services, these are the things that won't be working. There are 3 different application styles that we typically distinguish. The first one is productivity, the second one, utility, and the third one, immersive. Here are 3 examples of these things. Let's go through productivity first. Productivity are things that organize and manage detailed information. They are the closest to what you do on the desktop usually. You often organize data hierarchically. Mail is a good example. You organize the list, you add and remove items, photos, contacts. These are all productivity apps, right? They all often work in this way of drilling down and coming back out. These also typically use the standard widget set that iOS provides. Right? They all kind of look the same, and that's intentional because I don't want to reinvent the wheel and confuse the user with every productivity app. Whether I'm sorting through reminders or mails, things should feel, you know, familiar. Utility applications have a very simple task, like the weather app, for example. They use very little user input, and they have often a customized UI that's trying to be visually a little more engaging, more attractive, enhancing the display information and putting it into the context of that utility app. It's a one-trick pony, right? The utility, the weather app shows you the weather, and that's it. I can't, you know, send reminders with it. Data is often, therefore, not organized into hierarchical groups, but just in a flat list of items. Stocks is another example, right? Weather stocks, or this beautiful application that just shows you the periodic table of the elements with great, you know, gorgeous imagery for every element, what it can look like in different states, and so on. And thirdly, we have immersive applications. Games are a part of that, of course, but also things like, you know, the what's it called, the level application on the iPhone. We would say, what do we say for a level? Never mind. It would be German. So these often use very rich full screen interfaces, and they focus really on the content and the user experience. These often hide most of the UI, and they often also use custom navigation methods. Here are some examples. Living Earth, for example, is just a view of the Earth, and you can just spin the globe and zoom in on cities and see the weather in these cities and stuff like this. It's to enjoy yourself, right? Or the Carpenter level app here that I was showing. this is something that doesn't use standard user interface, especially except maybe for those buttons there, but even those have been skinned to fit the overall design. It's also a pretty skeuomorphic design that is trying to look like a real level in this case, which is something that sometimes makes a lot of sense. Sometimes it doesn't make so much sense. It's really a design choice. As I said, games often don't use standard buttons. In fact, a game that uses lots of standard controls will look kind of ugly and off-putting and boring because it feels like work if you're like, you know, going through drill down lists of items, for example. All right, so let me wrap up. Today, after a little bit of administrivia, we've given you an idea of what's different about designing for mobile. And I wanted to put this at the beginning of this class because you need a different mindset when you're designing and programming and coding for mobile. You need to think about who your users are. You always need to do that. You need to remember that the task that they're in is very different often from a task at a desktop. And you need to think about the context where they are using your application. What else is happening around them? Are they together with other people? How much time do they have? Do they pay attention to the app or not? You got to keep the hardware restrictions in mind, not just screen size, but also battery life, limited processing power, different kinds of sensors and stuff available. Although in that respect, often smartphones have more available than your typical desktop. So there are hardware restrictions, but there are also opportunities for things that you can do on a smartphone that aren't easy to do on a desktop, like face recognition if a desktop doesn't have a camera. And there are, of course, different application styles that we shared. The three ones that we talked about: productivity for standard interfaces, utility for things like weather, etc., and immersive like games and simulations. Now, further reading material would be the iOS Human Interface Guidelines are an excellent way to get started to understand how to design for iOS. And there's a nice Everyone Can Code website also that gives you a very easy entrance into the topic. What do you need to do now? You need to register for the class if you haven't already. You need to sign the Declaration of Compliance linked off our homepage, of the iOS homepage, and you need to send those to us, the declaration, sorry. Send it to Phil, not to me. I don't need to receive these. I would only forward them to Phil anyway because he's keeping track of them. Next lecture is on Monday, the 18th, 12:30. And we will give you an idea of how the Swift language works. And we will also already give you an idea of the seminar topics that we will be covering later, so you can start thinking about what kind of seminar topics you might find interesting. With that, thanks everybody again for dialing in here. We still have over 100 participants in the call here. That's really amazing. I'm glad so many people are interested in doing this. We're very sorry that we can't offer everybody here a seat in this class this semester. But if you don't get one, don't be sad. Tag along anyway if you just want to learn iOS coding and don't need the detailed feedback from us, or sign up for the class next semester for credit, and then you can let us know if you've already tried to sign up once in vain, and we'll try to keep that in mind as we pick groups. Okay, Phil, any other words that we need to that you need to add to this?
No, just the general reminder. Tomorrow afternoon, I will then invite everyone who sent me the Declaration of Compliance and registered in Avatar Online to the Moodle room, so that you can there find groups and other students to form a group with, and then send me the details by Friday, and then we'll pick who or select those who get a seat in the class.
Right, Friday by 1
p.m. So then you will know, just seeing the question, you will know Friday afternoon whether you have a seat in the class or not.
Right. Also, I see the chat was very busy. Have you been able to keep abreast of that, Phil?
Yeah, I think I got everything. If I missed something, just drop me a mail and I'll get to it.
Awesome. Thanks everybody for joining, and enjoy the rest of your day.
This content was provided by RWTH Aachen University.